Hey and welcome. Today we will solve contains duplicate interview question. This question mostly asked by Google as well as some other companies like so. We will explore 3 solutions for this problem. So without further ado, let's dive in. Let's see some examples. We have double ones, so result is true. Second example, we don't have any duplicates, so we might return false for it. And last example, we have ones, threes, fours, and twos all over the array, so obviously true for this one too. Let's see how we are going to solve this problem. As of our first brute force solution, we can do a double for loop and check each number like that, but nested for loops means O of n in power of 2 time complexity for us, which could be super slow for bigger inputs. As of our first solution, in this case, we usually need some sort of lookup for storing already visited values. Think about having a hash map and storing every visited value while we iterating through our input nums. Then we can easily check for each number during our iteration, and if we already have stored it in our hash map, we would know that that's a duplicate. With that, we will have O of n time complexity, but we also going to have O of n space complexity because of hash map. Another similar easy solution could be uniquifying our input nums with a JavaScript set and check for lengths of both nums array and our set. If they are equal, that would mean that we don't have duplicates because JavaScript set will only keep unique values. But if the size of set is less than array, that would mean there was some duplicate values that set skipped them. And yes, literally these 2 lines of code for this solution. But again, we will still going to have O of n space complexity in this case too because of set. In order to get rid of space complexity, we can sort the array and check for each adjacent values, because now if we found 2 numbers next to each other equal, then we found the duplicate values and we can easily return true. But as you might guess, sorting array has its own price, and at the best case it's O of n log n, because mostly JavaScript engine uses merge sort. But all in all, it's a matter of trade-off in this problem. If we want to achieve O of 1 constant space complexity, we will have a bit higher time complexity. As you can see here in the chart, O of n log n is above O of n and will dominate it. But if we want to have O of n for both time and space, we already have 2 solutions for that, hashmap and set. So let's implement all of these solutions. Here we are in leetcode. Let's implement the first solution, hashmap. We will have a scene object like const scene equal to empty object, then our loop over nums array for let I equal 0, I less than nums dot length, and I plus plus. Inside of this for loop, we will check if we have this number already in our hashmap. So we will do if scene nums at index I, is it there? We should return true. Otherwise, we should add it into our hashmap. Else scene nums at index I equals true. At the end, if we have finished our iteration and found nothing, we will return false. We will do return false. And now if I run this, every test case is passing, and if I submit, everything is fine. Let's implement the set solution. This one is just 2 lines of code. So first we will create a set of our nums array. We will do const nums set equal to new set of nums. Then we will return the result of our comparison. We will do return nums set dot size not equal to nums dot length. So again, if I run this, test cases are passing, and if I submit, we are in a good shape. Let's implement the sort solution. As we saw in the slides, we will first sort our array. So nums dot sort is a minus b. That's the sorted version. And let's do our iteration over sorted array for let I equal 0, I less than nums dot length, and I plus plus. Inside of our for loop, check for adjacent numbers. So we are going to do if nums at index I is equal to nums at I plus 1. If that is the case, we should return true here. And if we finish our iteration and found nothing, we can return false. And now if I run this, test cases are passing, and if I submit, everything is fine. So let's jump into the slides for time and space complexity analysis. For time complexity, we will have O of n for both hashmap and set solutions since we are iterating over our nums array. Also, we will have O of n log n for sorting solution because we sort and then iterate over our array. Sorting costs us n log n time complexity, and iteration is another O of n. So n log n will dominate O of n, and as always, the biggest we care about, as we seen in the time complexity chart. And in the worst case, we could have a long number of arrays in duplicate values could be placed at the end of array. That would mean we have to traverse all of the array. For space complexity, it is going to be O of n for hashmap and set solution, and constant space complexity for sorting solution. With that, I can say that was it for this video. Make sure to subscribe to the channel in order to not miss out new videos. I also will put the link for arrays playlist in video's description, where we solve multiple array problems from LeetCode. So thanks for watching, and please like, comment and subscribe to the channel. And finally, hope you enjoyed this video and stay tuned for the next one.